rewriting sucks. So we want you to keep as much code as possible operational so that you can move even faster. Even in Greenfield apps, you have some amount of native code, some amount of native logic that's running a React Native app. But in Brownfield apps, you actually have an actively developed native app. You might have SwiftUI screens, Swift screens, Kotlin, Jetpack Compose screens, and then you add React Native screens on top of those existing stacks. In Greenfield apps, React Native owns the app, but in Brownfield, it might be the vice versa.
There are multiple things to consider when you are doing Brownfield, because Greenfield is essentially Brownfield, but with just one screen where React Native takes over.
In order to do Brownfield in the olden days, you'd have to, let's say, copy React Native repository, get some files from there, move them to your project, remember which versions you copied them from, and then modify it so a lot of native knowledge needed. And not only native, but like native, React Native knowledge needed. And then you'd have to maintain that custom implementation with each new version of React Native that you want to pull into your, package JSON or something.
Yeah, I think it's just a lot of effort. You would need like a master's degree in React Native and native development in general.
Or you'd need to hire Callstack, which is the total software engineering consultancy that does this podcast. I'm a terrible host of this podcast. Sorry for that. I promise not to do any more digressions.
React Universe on Air, your go-to podcast for all things cross-platform.
Hey everyone, this is Łukasz, and you already know the podcast you're listening to. This is a Coffee Talk edition. Today we're talking about Brownfield integration in React Native, and to do that, I have two wonderful guests, my colleagues from Callstack, Burak and Oskar. Can you guys please introduce yourself?
All right, so my name is Oskar Kwaśniewski. I'm a senior software engineer here at Callstack. I'm doing like all sorts of open source things around here. And yeah, that's pretty much it.
And I'm Burak. I will call myself a Brownfield enthusiast, and that's it.
Okay, that was pretty short. For me, you guys have a really great job at Callstack, working with open source, bringing the tools to the community, working on the tools and not working for the clients, because working for the clients is, sometimes hard. I'm not saying that open source is not hard. Sorry for that. Before they fire me, let's go back to the episode. So we're talking about Brownfield today, and we already had two different episodes of back then the React Native Show podcast about Brownfield. So if you want to know some ground rules, we will explain them as well, but if you want to know some more ground rules, go back to episode 6 with Mike Grabowski and Mike Chudziak, and to episode 13 with me and Mike Chudziak as well. And in that episodes, we were explaining the origin of the term Greenfield, Brownfield. So maybe let's not explain it anymore on this podcast. What I want to ask you guys about is, what is the craziest setup for Brownfield in React Native that you've seen in real world?
So the craziest setup that I can think of is, if you have native apps, you probably also have some complicated custom setup that you want to keep. And as a result, that also complicates the Brownfield integration. So one example in this case is, you can imagine you have all those third-party SDKs like Firebase, Braze, all those analytics SDKs, or any other third-party framework that you can think of. So if you're an iOS dev, you are probably familiar with those XE framework files or Swift Package Manager packages. So what happens when you try to integrate React Native into this setup with already existing third-party frameworks? So in this case, we have a couple of options. And one of those is we get all those framework files, those third-party frameworks like the Firebase framework. And then we try to also make it work with React Native's Firebase SDK. So there's a package called React Native Firebase, and there's a hack that makes it possible for that React Native package to use the third-party framework that you already have, so that you don't have to keep the same framework bundle twice in the app. You can share
because usually when you get React Native Firebase, you install it as a React Native dependency that brings its own native dependencies.
Exactly. So it brings its own, on iOS, it brings its own .xc framework file. And that file is a library with native code.
So is that approach that you said it's a hack, is that approach like transferable to other libraries that have native parts as well?
Kinda.
Okay. What about the compatibility between that?
So that's always a problem, right? Because you don't want to get vendor locked because of React Native's versions. And in this case, like the React Native Firebase was behind in Firebase versions. So like you might have to adjust your own version just in case.
Cool. So right from the start, we dive deep into the technicals. I ask maybe too complicated question. I expected maybe some more short answer.
I can give you a simpler answer, like what I saw. So once there was this benchmark of like new architecture I seen, and like there were two tabs. It was actually like a Brownfield app made by Meta, where one tab was the old architecture and the second tab was the new architecture. And they compared like old to new one. But this would work mostly only with React Native, because there are some, most of the package creators actually have some if-defs around the new and old architecture. So if you try to run your app in like one tab with new architecture, in the second tab with old architecture, it wouldn't work with third-party dependencies, but you can, test, for example, your library like this, if you would like to like test new and old architecture in the same time, because this for library maintainers, this is a pain because you have to rebuild the app constantly and check. So yeah, this is one of the examples I saw.
I don't think that it's like practical to do that in this case. Like I cannot imagine why would anyone want to do that.
In the app, sure, but in the library, it's like in the library test app, I mean, it's a good option. Like I've tried that, it worked, but then I rolled back to the default version. So yeah, you probably shouldn't do that in your app, but it's good to know there are possibilities like this where you can like really shape React Native to work however you need it to work.
Yeah, because like usually going Brownfield is more like web developer job. You usually don't want to mess with native files, etc., etc. But Brownfield is a whole different animal where by default you need to deal with native dependencies. Or do you? I don't know. Maybe this new version of React Native Brownfield deals with it for you. So I said go back to those two episodes to learn the basics. Maybe let's, just for me, okay? Burak, Oskar, just for me, can you give me some basics about like Brownfield in React Native? How do I think about it?
Normally, and I say normally, but there is no like normal application in this case. I would say like Greenfield in this case. So in Greenfield React Native applications, you would have React Native and it would have some amount of native code. Like it would have its own app delegate, it would have its own main activity, as long as you're not using Expo. But even if you're using Expo, that all those stuff are handled for you in the background.
Meaning the shell native app that runs your React Native engine, let's say.
Yeah, so like you have to have at least some amount of native code that's running your React Native bundle, loading everything, and just like letting it run. It hands over the ownership of the application to the React Native bundle with a Greenfield app. So even in Greenfield apps, you have some amount of native code, some amount of native logic that's running your React Native app. But in Brownfield apps, you actually have an actively developed native app. You might have SwiftUI screens, Swift screens, Kotlin, Jetpack Compose screens, and then you add React Native screens on top of those existing stacks. You can have separate navigation stacks that handle React Native navigation and all this kind of stuff. So the main difference is in Greenfield apps, React Native owns the app, but in Brownfield, it might be the vice versa.
Yeah, so like there is also this case where because in Greenfield, you get to the app. Did finish launching with options. This is the method on the native side that gets called whenever your app finishes launching, and then React Native gets initialized and it like takes over the whole screen. So it views the screen. But in Greenfield, there might be a case where, for example, your main screen is native, like it's built with UIKit, but then you get to the, for example, settings page that's built in React Native, and only then you want to initialize React Native, or where, for example, user is approaching this tab, like you may have some custom logic where you want to like initialize, start, pre-warm React Native, start initializing it in the background, and then create the view whenever user actually hits that tab, because he may never enter the settings. So there are multiple things to consider when you are doing Brownfield, because Greenfield is essentially Brownfield, but with just one screen where React Native takes over. So yeah, that's essentially the main difference.
Yeah, it's when Burak was talking about that this is a shell app and it requires some native code. Actually, there is a bunch of native code there. Like that's the whole app, right? We don't see that code as React Native developers. We mostly don't see that code as native developers as well, because like we care about only like our entry points and then we build our own files. But it's there, and I wonder if you start a new Greenfield app and you push it to GitHub, what's the percentage of like JavaScript versus Swift versus Java versus Kotlin, etc., right? Like, what's the percentage of lines of code that are actually native?
I would say like you have your app delegate in Swift, and that's all the Swift code, apart from maybe like main.m, the Objective-C file. So like only a couple of files on iOS and only a couple of files on Android. I don't think that it's, so like obviously the percentage depends on how much TypeScript code that you have or JavaScript code, but it's not that much in comparison to an actual native app.
Yeah, so I got the data. I've checked it. It's for React Native, let's say 79. So I'm checking this on the React Native community template, how much the template actually has JavaScript, Kotlin, and all sorts of things. So it has 56% of JavaScript, 13% of Kotlin, and now 7% of Swift, no Objective-C, and 9% of Ruby, which is like mostly for CocoaBot's configuration. And now it's also 5% of TypeScript. So I think the 56% of JavaScript comes from actually some scripts that they have in the community template. So like they have some scripts to release it. So yeah, the amount of native code is not that big. Most of the native code for React Native actually sits in React Native package.
That actually blew out my assumption. My assumption was that when you create a fresh project, the native files will have much bigger share of the actual code base. Thank you. And for everyone listening, we didn't prepare this question beforehand, and Oskar actually find that out in like 15 seconds. So congrats, Oskar. You're great at Googling. Already got a native app and you don't want to rebuild it from scratch? You can layer React Native on top and start taking advantage of cross-platform features right away. If you're not sure how to start or just want to talk it through, reach out to us at Callstack. We've done this plenty of times and we're happy to help. We covered Greenfield, Brownfield, like what is actually happening in those approaches, like on the high level. So let's maybe go lower level and talk about how historically we were doing Brownfield.
So yeah, in the historically, you would need to basically copy everything from. I'm going to talk about iOS because that's mostly what I'm now and what I'm mostly familiar with. But the approach was similar to Android. So let's talk like more high level, but for iOS. Burak, you can fill in on Android if you want to.
So you got us too, and we both expertise on iOS, not Android.
Yeah, that's true. So like on iOS, there is this RCT app delegate, which is a class that you subclass for your like main entry point of the app. So the app delegate is the entry point for your iOS app. And this is where the like did finish launching with options function gets called, as I said before. So there was this abstraction React Native RCT app delegate that inside of it had all of the implementation details of how to initialize React Native. So you had like your creation of the bridge, and then later on with the new architecture, creation of the RCT instance, and all sorts of things like that. I had a presentation like last year on some conference showing the actual amount of code, and it didn't feel on the one slide. So it was like scrolling. So you had to copy all of this from React Native to your project to have Brownfield working. And then when, like, for example, I don't know, React 72 or 73 came out, you had to update everything to account for this new version. And like switching to new architecture and old architecture also wasn't that easy, because you also had to maintain this code for switching. So yeah, this was a pain for sure, like working on this old architecture, new architecture stuff. So you had to basically always subclass this app delegate in your app. And this wasn't ideal for like integration to native projects, because you may want to, as I said before, initialize React Native whenever you hit this settings tab in your app, not like immediately as it is in Greenfield.
If I can try to dumb it down a little bit for my own sake, in order to do Brownfield in the olden days, you'd have to, let's say, I don't know, copy React Native repository, get some files from there, move them to your project, remember which versions you copied them from, and then modify it. So a lot of native knowledge needed, and not only native, but like native React Native knowledge needed. And then you'd have to maintain that custom implementation with each new version of React Native that you want to pull into your, like, I don't know, package.json or something.
Yeah, I think it's just a lot of effort. You would need like a master's degree in React Native and native development in general.
Or you'd need to hire Callstack, which is the total software engineering consultancy that does this podcast.
Yeah, and on top of that, the whole code in React Native was in Objective-C. So like if you wanted to integrate it with Swift, you had to also translate it to Swift. And like it doesn't work that well in Swift because it uses C++ under the hood. So yeah, it wasn't easy. You had to like create wrappers around Objective-C so you don't expose C++ in headers to Swift, because then Swift like blows up and it doesn't work. So yeah, this was a nightmare, and I'm happy that it's over.
As far as I know, that's like the way that, let's say, custom Brownfield integration worked. But we have had this React Native Brownfield app at Callstack for years now. So what's up with that package? How that package back in the days helped me out with all of that you just described? That's the first question. And the second question, how that package evolved, and why are we talking about it right now?
Back in the day, there was this issue, as I described. Let's focus only on old architecture, because like new architecture wasn't a thing for a couple of versions behind. Before, this package was mostly doing this thing. So it encapsulated the whole logic of creating this new RCT RootView, it was called before, which is just a UI view on iOS that you can use, for example, to implement this settings screen in your app. So React Native Brownfield allows you to have an easy way to initialize React Native, so to create the everything that you needed, so the bridge and all sorts of things like that. So you could call one function that would initialize, like set up React Native, and then call another function that when you needed a new view, it would create it for you. So you would just display it in your UI as a normal UI view.
So basically, like quality of development utility library.
And it also like helped you with the navigation. So for example, whenever you have like native navigation, you navigate to React Native. Let's say you do a push to navigate to React Native. Then inside of React Native, you also have your native stack. So you push new screens. And whenever you get to like the first screen, so users goes back, then it's on the last screen of React Native and wants to go back to native. This is an issue. So React Native Brownfield exposed a method that you can call, which was called pop to native. And you can then go back from React Native back to native. So you could like seamlessly transition between native and React Native.
I imagine like going off topic from React Native Brownfield a little bit into like Brownfield in general. I imagine this barrier between native and React Native, like that's the like most tricky part to deal with. Not only in this example in navigation, but like across the board, right? Like the barrier is the tricky part.
I think when you have two systems that has to talk to each other, that's like the trickiest part. Like you can also think about backend and front-end communication. Like you had all those API layers that are trying to like go odd over the years because people now understand that this is the biggest barrier for development. So they are trying to unify backends and front-ends, like a lot of approaches with React Server components and everything. So you might also think about React Native, and I would say like native versus JavaScript code, you have to communicate. And I think that's the trickiest part with the Brownfield approach.
Okay, sorry, Oskar, for interrupting you. Back to our episode about React Native Brownfield.
Yeah, so, okay. Only for old architecture. So this is important because it didn't work for new architecture. Now it works. But in order to get React Native Brownfield to the state that it is today, we had to implement a couple of things inside of React Native Core. So like the whole backstory behind how these changes happened inside of React Native is that we worked on React Native visionOS, which requires us to use SwiftUI. So in order to use SwiftUI in React Native, you had to basically rewrite the whole flow of how you initialize the like React Native in your app. So basically you had to write React Native like Brownfield for SwiftUI inside of the project. So I wrote this in order for people to like use React Native visionOS because it was the only way there to create native views. And SwiftUI works kind of differently because it requests the views from you, not like it has one function that initializes the view, like update, finish, launch with options. You can also have multiple screens in there. So that's a bit complex. So I was working on React Native visionOS, and there was a need for me to unify how React Native works, because every time there was a new release, I had to change everything. And as I told you, this was the pattern before. But I had to change it for new architecture and old architecture. So I started to work with Ricardo from the core team at Meta. And we came up with this API, which is to use RCT RootViewFactory. So this API like encapsulates creation of the new view. And at the time, I was thinking like this is perfect. Like this is all we need. We just use RCT RootViewFactory. So this was like a pretty big PR I've created to React Native. I worked on it for a while. It got merged. And suddenly, like after a few releases, you had to still use the RCT app delegate. So it wasn't the solution. Like people from Meta started to add things inside of the app delegate they didn't add to the RootViewFactory. So it was kind of getting out of sync with like how I wanted it to work like. So yeah, it kind of worked, but you still had to do some manual steps in order to get the RootViewFactory working. So then I sat down once again and created ReactNativeFactory. So there are a lot of factories, but ReactNativeFactory, it's like its main goal was to like completely remove the RCT app delegate thing, which is subclass. So now you don't need to subclass. anything. You just create a new RootViewFactory. And from that RootViewFactory, like it encapsulates the creation of a React Native. So it sets up the React instance and stuff like that. And it also has the logic for setting up old architecture and new architecture. So once you create the React Native Factory, you can then use the previously mentioned RootViewFactory, which allows you to create the views.
And this will be the final factory, right?
Yeah, this is the final factory. No more factories. So yeah, this was a long road. Like it took a while to implement this. It was like I was refactoring the whole React Native initialization flow inside of React Native while, everyone was still contributing to React Native. So the PR was constantly getting out of sync and like had conflicts. But after like few months, I would say, we managed to merge it. And now in React Native 79, the RCT up delegate is finally deprecated. So it's like the transition period. Now you can use the React Native factory like without the RCT up delegate. And in the newer versions, we will like completely migrate off RCT up delegate and set up the React Native inside of your app delegate, like in the template, which will make kind of React Native be brownfield first, because then you can just look at the template and copy whatever is there and initialize it in your native app. So there will be no longer some abstractions that you need to subclass, which is not ideal in this brownfield scenario, because some people may already have some subclasses in your app delegates or whatever. They don't use app delegate, they prefer scene delegates. So yeah, this was a long way from visionOS now to React 080, which will have this enabled.
I really tried. Thank you for this. It was really deep, and I really tried not to interrupt and get you off your track. I have 3 notes that I needed to write down before I forget them. React Native Factory, great name for React Native software house or something. React Native if you start React Native Factory software house, I get I don't know what's that called, like a percentage of your gains or something. So second topic that I have noted down, again, shameless plug. We did episodes with Oskar about React Native visionOS about a year and a half ago. And back then, he was talking about those factories, not all of them, but the changes that he had to make to a bunch of different repositories, React Native included, React Native Core included, to make it more like pluggable, to make it more pluggable for other platforms, for new platforms. So that's part of that effort. And what you just explained to us is that after that missing piece for visionOS, there were still needs to like generalize it, to generalize React Native architecture to be even more like extensible for not only other platforms, but also for like different kinds of projects. So those changes that you just described were to the core repo, and not really, we haven't really been talking about React Native Brownfield changes. So let's get to that maybe.
Sure. So yeah, this was the foundation we needed to lay for React Native Brownfield to be great again, to be back. So now that we have like all these APIs inside of React Native, and we have Meta maintaining them, so they're keeping them up to date. Whenever something changes, I don't know, they add some new thing to React Native, we don't have to add it in React Native Brownfield. And yeah, you can just use them from React Native. Burak, maybe you want to, because I've been talking about a lot, so you can.
So I guess like the biggest additions to like the Brownfield I would say the library React Native Brownfield, to make it possible, you had to do a lot of changes in React Native itself. So yeah. I wouldn't say like we have written a lot of code, we have like experimented a lot. I think the biggest contribution that we had with React Native Brownfield was that we have pushed this trend in React Native repository itself. So like I would say the actual changes were in React Native repository instead of the Brownfield library repository.
Yeah, exactly. So do you want to, because you recently released an article like going over the cool things about React Native Brownfield and what it unlocks.
This podcast is one big advertisement for our blogs, for our podcasts, for our open source work. I don't know. Sorry, that's a joke. Go check out the article, definitely. We will link it in the show notes.
Yeah, we have all these new features with React Native Brownfield that are awesome. So to sum it up, you would previously need to create UIKit, SwiftUI, Android views manually yourself by calling React Native internals. Now we have some view loader APIs that can load SwiftUI views, UIKit ones, Jetpack Compose views, all of them handled for you. So you don't have to use those React Native, I would say internal, but they're not internal APIs. So you wouldn't need to use those APIs. That might be a bit too low level for you. You can just use React Native Brownfield. It has a native facing interface, so it's not a JavaScript only package. You can import and use it from Swift and Kotlin code. So you can just use those APIs to create those views, those React Native views, using the package instead of doing everything yourself.
On top of that, like we have this approach of packaging React Native as a framework, which Burak is an expert in. So
I wouldn't say expert.
Yeah,
can you first explain what does it mean to package React Native as a framework? And like, what's the other way? Like, what are the two ways how it works?
Okay. So I would say there are two ways that you can create Brownfield apps today. One is, if you are already familiar with React Native, you've probably seen a repo like this. You got an iOS folder with a project, an Xcode project. You got an Android folder that has a build.gradle file inside it. And then you probably have an SRC file with TypeScript, JavaScript, flow code that you have.
That's the standard template.
I guess so, yeah. This is the standard template, and you can do this approach with the Brownfield apps, but you might guess that this would require you to get all your native apps in a single repository, and that's not good news for everyone, because you might have some specific CI jobs, you might have some pull requests, I don't know. So you have to like change all the way that you work, you have to change all the repos that you have to add React Native. And obviously we don't want that. We don't want you to disrupt your whole work just to use React Native. So that was the kind of legacy approach with Brownfield apps. So the second way to do this is, you might have guessed, like, normally when you have libraries, like let's say JavaScript libraries, you normally upload them to NPM so that it can be consumed by other repositories, let's say. And in this case, what we do is, iOS has this native packaging format called .frameworks and .exe frameworks, and Android has .aar files. So you can think of these as you have NPM packages and you have package.tar files. You can think about those native files as those tar files. So what we do is, we take all the React Native code, and when I say React Native code, it's JavaScript plus all the native dependencies. Like React Native depends on Boost, it depends on Facebook's open source libraries and everything. So those framework files have everything packaged for you. So you can just add it to your native application and then just use React Native. That's it. You don't have to install Cocoa Pods, anything else on your native apps just to use React Native, because we know that you don't want to see pod file in your native app that uses Swift Package Manager. It's not elegant. So we just package everything from one React Native repo that you don't even have to like look at it. You don't even have to know that it exists. It just exists and sends packages to you. And you, as a native dev, can just consume it and use it.
You're listening to React Universe on Air, your go-to podcast for all things cross-platform with React and React Native.
From talking with Mike Chudziak, I don't know, it was like 3 years ago or something, on that episode 13, he stressed that it's really important for brownfield projects that want to integrate React Native in, let's say, big enterprises or something, is that we, like you said, we don't disrupt the flow of existing developers. If we have an app that has like, I don't know, hundreds of native screens already, and we want to enable React Native for people that want to use it, but then we don't want to interrupt everyone's workflow, we don't want them to build React Native or start Metro or anything like crazy like that. They should be able to work with their app as they are used to. And we are just adding on top of that another library, another utility that just allows you to do React Native.
So I guess like one way that I like to think about those React Native screens is as a replacement of web views. And the reason is you normally have web views, they might use React even. And you have a special communication pattern with web views. You have to like use some window.event listeners to just like communicate with them. And you kind of have the same approach with all the React Native views, except React Native can also have its own native stack and it's fully native. So you can also use native APIs. You don't have to write custom code just to delegate all those native calls.
Talking about native and React Native and that like integration layer between communication layer. Let's go back to that boundary that we discussed, and let's maybe talk about what can we share, what should we share, what can't we share between the two words.
So that's a great question, and my answer is, as always, it depends. It depends on your use cases. So it's always costly to send data between two systems because you have your native Swift types, you have your native Kotlin types, Objective-C types, and you want to convert them to JavaScript types somehow. There are a couple of ways to do that. You can use JSON, you can use JSI for direct access. I'm not going to go into detail, but this always comes with a cost, so it's not free. So it's always a pros and cons of sending data between platforms. I would say if you want the absolute best performance, it's always better to send as little as data as possible.
Let's say I have an app. I have my app state, my global app state. I have like different screens written in different technologies, but I still want them to share the same data, to have the same user logged in, to have like the same products in the shop cart or something like that. So like what's the best practice there?
I guess now we are on a different realm because previously we were talking about sending data from native to JavaScript layer. But now we have JavaScript to JavaScript communication. And good news is that JavaScript shares the same context. And I guess like Oskar can explain it much better than me because he's been working with all those internals, bridge.
I wanted to add to the before, like passing data, because you can always pass initial props from native to React Native. And this is probably the easiest way that you can pass data. So it kind of works like, I don't know, server components, kind of. Like you pass some initial data and you receive it in props. So yeah, I wanted to add to this, to the previous thing we were talking about, that this is probably the simplest and the fastest way you can pass something down. But Burak, please explain what we can do about like sharing the state across, because this is a tricky topic.
And I think like maybe like my question comes from my like general understanding of the apps. Like probably like the biggest thing that you want to share between those two realms is like your app state, right?
Yeah, definitely. So like I would say at least you have to share some user token or something like that to show that you have logged in. I don't know, if you are doing whole navigation stacks, you might also want to like pass some props, but I think the best are, and when I say best, it's arguably the best, but I think it's always better to have less side effects in your code. So one way that I like to think about those React Native Brownfield modules is if you can keep those side effects as minimal as possible. And when I say side effects, it's something like, oh, I have a native app call that changes everything, right? And I think it's best to not call that from React Native. It's best to like still keep your native code there, but use React Native as if it's a function that doesn't have any side effects. So you pass it some initial data, and React Native screen state doesn't change based on the global state, so that it's clear what is passed between your native app and the JavaScript. And this way, you are minimizing all the communication between JavaScript and native end. So it's always better to keep the side effects to a minimum. And one question that I get often, and also this is a really good use case. you have React Native applications, which means you have React apps, which means you might want to use some client state management libraries such as Redux, or some server state management libraries such as React Query. And the question is, can I use it? Like just this, right? So the obvious answer is you can, but like generally there is an underlying question to that, and it's that, will it work? Like, let's say I have two different brownfield screens. Will it work between them? Will they work in sync? So the answer is yes. And the reason why the answer is yes is because when you initialize a bridge instance, this was the old architecture, and I think we have some similar API on new architecture as well. It generates a single JavaScript context for you. So if you have a couple of React Native screens that you use in your native applications, I don't know, maybe like you have a native screen that consumes two screens that are half-sized each, so they can communicate between each other using some sort of client state management library such as Redux, thanks to them being hosted in a single JavaScript memory. So they will know when each other change.
So say we go back to the example from Oskar that our settings screen is in React Native, and then I have completely different screen, like in completely different part of the app. Those two screens, by default, share the same JavaScript context. They can talk with each other. How about, and this will be another digression, I'm sorry. How about if I want to use like different React Native versions for those different screens? Can I create two different contexts?
Now you have some technical debt because probably not.
The native code is the same, but you can have, because like React Native Factory, it is a factory to create React Native new instances. So you can technically have two React Native instances and two separate Hermes instances for you to have two JavaScript contexts. And we actually used it on client project once for a POC, so that you could have like a safe environment to execute JavaScript. So you have one instance for React Native, and we create a new instance, which is totally separate JavaScript instance, totally separate Hermes, and like React Native, to have a safe environment to execute JavaScript separately from your main app.
So the use case is to force those two separate contexts so that they don't share anything between them.
The main goal was for AI to have a safe context to execute something, so that it doesn't create some side effects for the main app. Yeah, so it doesn't like inject something into global that can affect your main app. It has a separate global. So that was the main goal, to have a safe environment for AI to generate code. That was our main idea, but you can also use this, for example, for mini apps, where you have a separate mini app that has a new instance of React Native to also have a safe environment to execute.
But that also comes with its own overhead, right? It's not like...
Yeah, it's not free. Yeah, it's definitely, you have to create a separate React Native instance, which is a cost in itself.
Yeah, goodbye memory.
You've been talking about like cost in terms of like memory management, processing power management, or something like that. I also think about the cost of complexity and cost of like dealing with this kind of repository then. We already have a brownfield integration. Now we have to think about all of those other layers of complexity. Probably like the best practice approach would be to keep the complexity as minimal as possible, because we already are adding a lot of complexity. Like it's always a trade-off between like developer productivity, debugging time, and complexity.
So I guess like if you can keep the dependencies as minimal as possible, it's the best as it can get. That's why like I was talking about having code that is side effect free, so that it doesn't have a lot of dependencies between realms.
Okay, looking at my notes, I think we went over a bunch of things from like React Native Brownfield. Is there anything that we missed that you want people to know about, like using this technology?
So I guess like one thing that I would like to add is this, like today's, this might still require some sort of expertise in at least some native code in React Native. So it might be a like huge stopper for some teams to adopt this technology, but it's getting easier and easier, and we are working on this area to improve it. So maybe like today you're not able to find a lot of resources, but I would say like don't sleep on this technology. It has huge potential because rewriting sucks. So we want you to keep as much as code as possible operational so that you can move even faster.
I'm thinking what Oskar said about like adding all of those generalizations to React Native. I'm thinking React Native has matured so much in this like greenfield approach that the obvious way for us to grow, for our technology to grow, is to incorporate the brownfield and to embrace the brownfield, because this will open up for us new possibilities. And I think the market of cross-platform is going that direction as well. So Links.js, this new framework from ByteDance, I think it's brownfield first, and it allows not only React, but it allows a bunch of different like framework technologies. I think brownfield is the next frontier for us. New platforms are also like a way for us to grow, and it's exciting to see so much movement in our cross-platform space. Not only in React Native, but like I mentioned, Links.js, we can borrow and like learn from each other a lot, I think, in that regard. What do you guys think?
Yeah, definitely. I think like this is a great point to compete with React Native for links, because if you have a technology that's called links and you want people to use it, you cannot just be like, oh, like now you just have this and create a new app. No, that create a new app is what I think what's stopping people from trying these new technologies. I think it's the best that we let them use it as they want so that they don't have to create a new app. They can just use their own code.
I agree, 100%. And have nothing to add.
Yeah, maybe guys, you can tell us the last thing is to where can people find you? Where can people ask you question? Where is this React Native Brownfield library, docs, podcasts, etc.?
Yeah, so it's on our GitHub, on the Callstack, github.com/Callstack. You can find the React Native Brownfield. I think if you type into Google React Native Brownfield, this is the first thing that pops up. So check it out. You can find me on Twitter and GitHub. I'm there under the handle O_Kwaśniewski.
I just searched Oskar Kwaśniewski in Google, and your website is the first result for me. So you're easily Googleable.
You're not going to be able to find me. No, my name is so generic. Okay, so, and you can find me at x@_ATLJ.
Okay. We will link all of your profiles and all of the links in the show notes. And if you want to follow Callstack, we are easily findable on the web. Just follow us on everything. We started releasing those episodes on Twitter, on X as well, so you can watch us there. Let us know how you like this episode. We are waiting for your comments. And thank you guys so much for joining me. I had a blast this morning with my coffee and my Red Bull. And see you somewhere in the near future. See ya.
See ya.
Thank you. See you.